Welcome to my projectbazaar.com. Let me discuss about the process: an accurate ECG-based transportation safety drowsiness detection scheme. Let me discuss about the abstract of the project. Fatigue and sleepiness are dangerous conditions for drivers of any age. Drowsy driving is the operation of a motor vehicle while being impaired by a lack of sleep. Sleepiness can impair drivers by causing slower reaction times, compromised vision and coordination, lapses in judgment, and delays in processing information. To overcome the above mentioned problem, I proposed an accurate driver drowsiness classifier where ECG signals are detected by genetic algorithm with support vector machine. Here cross correlation kernel and a convolutional kernel have been proposed for extracting ECG signal information in order to detect the driver status. Driver drowsiness classifier is designed by extracting the cross correlation kernel and the convolutional kernel. This cross correlation kernel extracted the symmetric information of ECG signal, and the convolutional kernel extracted the antisymmetric information of ECG signal. After estimating the symmetric and antisymmetric information, can solve the multi-objective by genetic mutation of genetic algorithm. Cross correlation is a measure of similarity of two series as a function of the lag of one classifier. This is also known as the sliding product of. It is commonly used for searching a long signal for a shorter known features. Convolutional kernel is a process of multiplying each element of the image with its local neighbors weighted by the kernel. A genetic algorithm is a method for solving both constrained and unconstrained optimization problems based on a natural selection process that mimics biological evaluation. Finally, the accuracy of the classifier is compared with the existing system and achieved better accuracy. Let me discuss about the flow diagram for our process. Initially, EEG signal has been taken, and then the DC drift, that is DC drift elimination, LPF and HPF performed for pre-processing. In the DC drift, the resistor from amplifier side to ground is to ensure that any input bias currents from the amplifier's input terminals. Next, in the low pass filter is a process signals with a frequency lower than a certain cutoff frequency and attenuate signals with frequencies higher than a cutoff frequencies. And in the high pass filter is a electronic filter that passes signals with a frequency higher than a certain cutoff frequency and attenuates signals with a frequency lower than a cutoff frequency. Next, in the QRS detection stage, the QRS complex is the name of the combination of three of the graphical deflections in an atypical electrocardiogram. Next, in the segmentation, signal segmentation has been applied to TFI, which is segmented correspond to the frequency bands of the rhythms of EEG signals. Next, in the feature extraction, there are two features extractions are proposed. One is cross correlation kernel and another one is convolutional kernel. And in the cross correlation is a measure of similarity of two series as a function of the lag of one relative to each other. And whereas in convolutional kernel, a convolutional matrix or mask is a small matrix useful for blurring, sharpening, edge detection. This is accomplished by means of convolution between a kernel and an signal. And in the classification stage, here genetic algorithm combined with support vector machines are performed for classifying process. Genetic algorithms are adaptive heuristic search algorithm based on the evolutionary ideas of natural selection and genetics. The basic techniques of the GAs are designed to simulate process in natural systems necessary for evaluation. Next, in the support vector machine. Support vector machine is a discriminative classifier formally defined by a separating hyperplane among the many hyperplanes available. There is only one hyperplane that maximizes the distance between itself and the nearest data vectors of each category. Then, in this classification stage, we also given input from the train features and also labels. Finally, it classify. If fatigue means the we have to alert the driver by drowsy sleepiness of the driver, and if not fatigue means then the driver condition is normal. Let me discuss about the running procedure for our process. Select the main temple in the current folder, right example, and run for executing this process. Here we have to select any one ECG signal among the 14 signal, and after we evaluate selecting the ECG signal, we obtain the entire results and also performance graph. Once the process will be finished, we will analyze the entire results. This is the input signal of our chosen signal, and this is the DC drift elimination from our input signal, and this is the digital low pass filter response for our input signal, and this is the digital high pass filter for our the resultant of the low pass filter result, and this is the R peak detection of our low high pass filter results, and this is the cross correlation kernel features we have extracted from the high pass filter results, and this is the convolution kernel features it's also extracted from the high pass filter results, and we obtain the classifier results, that is driver status is awake, that is the driver is not sleeping conditions, and this is the QRS detection. The red color point triangle represents the R wave, and the green color square represents the Q wave, and blue color square represents the S wave, and this is the Q value distribution of ECG signal of awake SS1 and SS2 candidate. This is plotted between voltage and number, and this is the S value distribution of ECG signal. This is the R value distribution of ECG signal for our awake SS1 and SS2 candidates, and this is the QRS value distribution of ECG signal between voltage and number been plotted. This is the overall accuracy in percentage for our correlation coefficient features only considered. Here the classifier will be differ compared with many classifier, that is linear SVM, quadratic SVM, polynomial SVM, and RBF SVM, and this is here also overall accuracy for our convolutional features only considered for our entire SVM classification, and here overall accuracy in percentage for our correlation plus convolutional features, and for our SVM linear, SVM quadratic, SVM polynomial, and SVM RBF kernel. This is the overall accuracy for our various features. Correlation coefficient only consider, convolution coefficient only consider, and here we combine both correlation and convolution features for our linear, quadratic, polynomial, and RBF kernel functions, and this is the overall accuracy for our considering the kernel correlation coefficient, kernel convolution coefficient, and kernel drowsy driver candidate detections by varying the classifier, and here the final graph for our overall accuracy average delay of KDDC testing. Finally we obtain the results. Thank you.